Okay, Parker, thank you for the question. Here is going to be my explanation for that. All right, so we have the density of gold to be 19.3 grams per centimeter cubed. And I write it this way because in dimensional analysis, we use fractions. And the mass of the gold nugget is 29.2 kilograms. So when we use, and we want to know the volume measured in liters. So we want to make sure we use the units. So let's start with, we have the mass. We know that, and it doesn't matter. We know we're looking for liters. We can either start with the mass or the density, doesn't matter. But I like to start with what I have. I have a piece of gold in my hand, and that has a mass of 29.2 kilograms. And this right here, to me, it looks just like a conversion factor. All right, so I'm going to start with 29.2 kilograms, and I want to get rid of kilograms, so kilograms goes at the bottom. And the only thing I know how to convert is to grams. And here I see it, grams in my density, so that's a perfect thing I can convert to. So I know that there's 1,000 grams in 1 kilogram, because kilo means 1,000. So this is 1,000 grams, 1,000 grams. That means this value is the same as this value, and that's what you need to make sure happens in dimensional analysis. Okay. All right, so let's, so kilograms goes away, and now we have grams, and we're looking for volume measured in liters. So we use that, we use that, we're not going to use that anymore. But now we have this one right here. I don't want grams in my answer, I want liters, so grams goes to the bottom so that they can cross cancel. So I have 19.3 grams in this value here per 1 centimeter cubed. Now it doesn't say 1 right there, but when we say per anything, if it doesn't have a number, it means it's 1. Okay, hope that makes sense. So the grams goes away, and now we have centimeters cubed. Now that's a volume, but it's not liters. So now here's a conversion factor that you probably should get to know, and that is 1 centimeter cubed is the same as 1 milliliter. And you just probably need to know that. And then, of course, we don't want milliliters, so milliliters goes down here to cancel. Liters goes up top. So again, I'm just putting the unit that I want to cancel so that they're opposite on top and bottom so that they cross cancel. Same thing here. And I know that there's, for every 1 liter, there's 1,000 milliliters. And the reason it worked to just have you divide those is because we can see these 1,000s going away anyway. And that's why it did work. So don't assume it's going to always work that way. If you're going from kilograms or maybe kilograms to maybe a volume of milliliters, then this won't be there. And you can't do that. So always just use your units and convert using dimensional analysis in this method. Hope that helped. Hope that answered that question. Okay, the next question you had was on sig figs. So let's see, we have, it says, so we got 9.740 times 10 to the 4th power. And you had 3 sig figs, and the answer is 4. Well, that's because this 0 is significant. Otherwise, why would we write it? Because 9.74 times 10 to the 4 is the same value. So why do we need that 0? Because our measuring device measures to the 3rd decimal place. And that's why that 0 is significant. So zeros to the right of a number are only significant if there's a decimal place. If there's no decimal place, then yeah, they're not significant. So like in the number 500, that's only 1 sig fig. But if we have 500.0, that's 4 sig figs. These zeros now become significant because there is a visual decimal point. Here, there's not a visual decimal point. So that's the rule on that. Anyway, I hope that answered all your questions. Give me an email. Sorry, it took me a while to get back to the email on that. I was kind of busy this weekend, but I will try to be on top of things from here on out. Anyway, give me a email if you have any other questions. Thanks.